Hello, my dear 9 students. In the previous video, we have discussed a lot about separation technique. We have started with evaporation to separate volatile or non-volatile substances and centrifugation to separate substances that do not settle down when kept undisturbed for so long, so that by spinning at rapid speed, it is forcibly made to settle down. And we have even discussed about sublimation to separate sublimable and non-sublimable substances, centrifugation to separate the mixture which dissolves in the same solvent, and even about distillation to separate two miscible liquids that at least differ with um, optimum boiling point, and even about separation of immiscible liquid by separation funnel, right? Separating funnel. Now we'll move ahead. After discussing this separation technique, let's move ahead to discuss about how air that's present in the atmosphere can be separated, because air is a mixture, right? So let us discuss about how to separate air. So separation of components of air. Air is having various components like nitrogen, almost 78%, oxygen, almost 21%, then carbon dioxide, 0.03%, along with that traces of noble gases like argon will also be there. So it's a mixture of gases, but it's a homogeneous mixture. So in this homogeneous mixture, we can separate it by fractional distillation. We go for fractional distillation because it's a miscible liquid. It's a miscible mixture where it forms a homogeneous mixture. Secondly, we go for fractional distillation because the difference between the boiling point is less than 25 Kelvin. Air is initially cooled and compressed. Why it has to be cooled? Because in the gaseous state, it becomes difficult for separating the components of the gases. Hence, it is cooled and compressed. By reducing the temperature, we are cooling it, and by increasing the pressure, we are compressing it. When we do it simultaneously, air, which is in the gaseous form, will be converted to liquid. Liquid air is allowed to warm up slowly in the fractionating column. When it is allowed to warm up slowly in the fractionating column, each gases at its boiling point get converted to vapors. Okay, so liquid air gets converted to vapors and separate out. Gases get separated at different heights. So this is the apparatus used to separate components of gases. Here you can see air is initially filtered. Why air has to be filtered? Initially, air has to be filtered because to remove dust or unwanted particles. Unwanted particles or any impurities that are present in the air has to be removed. So filtration is done in the beginning. Later on, air is passed under high pressure. Under high pressure, when air is passed, it is slowly converted to liquid. So we are liquefying air here. Okay. After liquefying, hot air is passed through the condenser, okay, where water is completely passed, freezing water is passed, okay, freezing cold water is passed, and that water is continuously moving. So this is again to reduce temperature. This reducing temperature is again for liquefying. So this is also liquefying air. These both the methods, one is increasing pressure and decreasing temperature, will help in liquefying air. After liquefying air, cold compressed air, it's cool and it's compressed, okay, that's passed to a separator. This separator will separate only carbon dioxide. It separates carbon dioxide, and that comes out as dry ice, about which we have discussed in the previous videos. Later on, after separating, it mainly contain components like nitrogen will be there, okay, N2 gas, and it will have O2 gas, and it will have traces of noble gases. inert gases. Traces of inert gases, like organ is one such. So, after separation, it's passed through the expansion jet. In the expansion jet, liquid air is passed and it's passed through the fractionating column. In the fractionating column, fractional distillation column, it is slowly warmed up. Slowly warmed up. When it's slowly warmed up, first nitrogen comes out, then argon. At the bottommost, liquid oxygen comes out. That means nitrogen is having lowest boiling point, then comes liquid oxygen with the highest boiling point. So this is how air can be separated. Components of air can be separated. Got it, children? Shall we move ahead? Let me go ahead. Moving ahead, how to get pure salt from impure sample. For example, you know that in the seawater we have salt, that is table salt that we use, and it also have other salts, but mainly let's consider table salt. NaCl, sodium chloride. That sodium chloride, which is obtained by evaporation of salt water, seawater, is not pure yet. How can I make it pure? So purifying any salt from the impure sample is done by a process called crystallization. It is done by crystallization. What is this crystallization? What has to be done? It includes several steps, like initially we have to take some impure sample of copper sulfate. Here we are using copper sulfate. Copper sulfate is CuSO4. CuSO4 we are using, okay, which is actually blue color crystal. Blue color crystals, okay. So this copper sulfate crystals are taken, some sample which is impure, okay, and it's taken in a china dish, dissolve it in minimum amount of water, okay. We have to dissolve it in very less amount of water. After dissolving it, we will filter impurities out. When we do the filtration process, undissolved impurities get separated. Undissolved impurities separates, but there may be some dissolved impurities, okay, that cannot be separated because it is mixed with the water. So what we'll do, we'll evaporate the water from the copper sulfate solution so as to get saturated solution. We'll start heating the water. Until when the solution becomes saturated. What is saturated solution? We had discussed in the previous video that saturated solution is one such solution in which no more solute can be dissolved. So as no more solute can be dissolved, it's having maximum amount of solute, that's called a saturated solution. So we'll heat the water so as to we'll heat the content so as to evaporate the water, hence it gets converted to saturated solution. Once it becomes a saturated solution, we'll cover the solution with the filter paper and leave it undisturbed for a day. Okay, for a day or so. When we leave it undisturbed for a day or so, only copper sulfate solution, only copper sulfate particles or copper sulfate molecules will convert into crystal. Okay, so we'll get crystals of copper sulfate. CuSO4, copper sulfate. Okay, these crystals will be in blue color, attractive blue color, and it will have definite shape too. And it is also pure. Okay, so this crystallization process, what we'll do, we generally take the salt, mix it with water and filter the content so that the salt that is dissolved, if it is having any impurities that is undissolved, that will be separated by filtration. After filtration, we'll heat the content, okay, so that the water gets evaporated and solution becomes saturated. Once the solution is saturated, keep it undisturbed for a day or so that it cools down and salt will be depositing at the bottom in the crystal form. So let us see crystallization images. Okay, before going to the images of crystallization, what are the application of this crystallization? It's not just to get pure salt from impure one, as we have done for copper sulfate. It's also used for purification of salt that we get from the sea. Okay, so CLE, this is how they do evaporation process. After we get the salt, again it's sent for crystallization so that it's purified. Then it's also to separate the crystals of alum. Alum means potassium and aluminium sulfate. It's actually combination of two sulfates, any double sulfate. It's K2SO4, SO4, along with that Al2, SO4 thrice. This together is called as alum. Alum is anything that's actually a double salt, generally a double salt. So to separate the crystals of alum, we'll also go for crystallization process. So here is the crystal alum. Okay. So to get the pure crystals of alum, will also go for crystallization process. So this is how crystallization is used in our daily life. Okay, moving ahead. Yeah, how this water purification done? Let us understand how this water purification is done. In our daily life, we'll purify water with the help of aquaguard, right? What happens actually in the aquaguard? There will be different steps happening. Sometimes you have seen RO aquaguard, which follows reverse osmosis, or UV, where they use ultraviolet radiations to kill the germs. So various techniques will be used to purify the water. So this is general way to purify the water. Okay, so reservoirs that have the water may be impure one. Okay, well, every cities nowadays will have water purification systems. Okay, so from the reservoir water will come. Okay, in 7th standard there are this discussion of water purification is very well explained. I hope you remember that. Okay, so from the reservoir, water is taken and it's put to the sedimentation tank. It is put in the sedimentation tank because it helps the solids which are of larger density will settle at the bottom, to allow solids to settle at the bottom. After that, it is passed to the loading tank. In the loading tank, they'll add some chemicals that will help the less heavier or lighter particles to get loaded. The chemicals will mix with that lighter particles and makes it heavier, and it will settle at the bottom to sediment the suspended impurities. ಯಾವುದು ಲಿಕ್ವಿಡ್ ವಾಟರ್ ಅಲ್ಲಿ ತೇಲ್ತಾ ಇರುತ್ತೋ ಆ ತೇಲೋದನ್ನ ಲೋಡಿಂಗ್ ಟ್ಯಾಂಕ್ ಅದಕ್ಕೆ ಲೋಡ್ ಮಾಡ್ತಾರೆ. ಅಂದ್ರೆ ಕೆಮಿಕಲ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಮಾಡಿ ಅದು ಲೋಡ್ ಆಗೋ ತರ ಮಾಡಿ, ಅಂದ್ರೆ ಹೆವಿ ಆಗೋ ತರ ಮಾಡಿ ಕೆಳಗಡೆ ಸೆಟಲ್ ಆಗೋ ತರ ಮಾಡ್ತಾರೆ. Then it is passed to the filtration tank. Filtration tank will have different layers. It will have different layers like coarse gravel at the bottom. That means ಸ್ವಲ್ಪ ದೊಡ್ಡ ದೊಡ್ಡ ಕಲ್ಲುಗಳನ್ನ ಬಾಟಮ್ ಅಲ್ಲಿ ಇಟ್ಟಿರ್ತಾರೆ. Then little small gravels. Then we'll have fine sand at the top. Then we'll have water. When the water passes through these layers, it gets purified because at different layers we have different sized gravels or different sized particles. When water passes through those different sized particles, any impurities that is left in the water gets purified. This same thing happens naturally in our nature, in the rivers and all. Okay, rivers or lakes will keep the water purified by this technique only, because in the rivers also there will be rocks at the bottom. Okay, big rocks will be there, then thin sand will be there at the bottom. When the water passes through these layers, it gets purified. And in these natural water sources like river, lake and pond, Water purification also happens with the help of aquatic animals that lives, because they eat away the living and living things like zooplankton and phytoplankton. That's very small microscopic plants and animals found in the water is eaten away by those big fishes or aquatic animals. That also helps in keeping the water purified. Okay, and also there will be various fishes that eats the algae and all. So water purification is kept naturally, held naturally in the nature. So in the filtration tank, when the water is passed, it gets purified further. Then it is passed to the chlorination tank where chlorine is used, and this chlorine, as it is anti-infectant, it will kill the bacteria. Then it is passed through the pipes to all our homes. So this is water purification system, how it works. Okay. So till now we have discussed a lot about how purification is done and how separation is done. We are left with the last concept about changes around us and difference between elements and compounds. I'll come shortly with the last video of the chapter, is matter around us pure. Thank you. Keep waiting for the videos, and please subscribe my channel if you have not done it, and share with your friends and family so that it reaches many of them who are in need. Thank you. Hope you are liking the videos. Thank you again.